Hi guys, so today we'll be solving this problem called Bitwise XOR of all pairings. Let's read the problem. You are given two zero-indexed arrays, nums1, nums2, consisting of non-negative integers. There exists another array, nums3, which contains the bitwise XOR of all pairings of integers between nums1 and nums2. Every integer in nums1 is paired with every integer in nums2 exactly once. Return the bitwise XOR of all integers in nums3. Right. So let's understand this. So first of all, we've been given two arrays, so nums1 and nums2, and it contains non-negative integers, which means that it always contains positive integers. And they are saying that there exists another array nums3. So nums3 is basically what? It is the XOR of all pairings of integers between nums1 and nums2, which means that if nums1 has 2, 1, 3, nums2 has 10, 2, 5, 0. So nums3 is basically the pairing of these two arrays such that it's a pairing of XOR of these two arrays where each element is XORed with the element of the other array once, right? So 2 is XORed with 10, 2, 5, 0. Then 1 is XORed with 10, 2, 5, 0. And 3 is XORed with 10, 2, 5, 0, right? So whatever is the value, it's basically the nums3. And we need to return the bitwise XOR of actually nums3. So all the elements of nums3 are later on then XORed with each other, right? And whatever is the answer, we need to return that, right? So that is the basically the approach question. So what we can do is one is like very simple brute force. What we do is we pick one element of nums1 XOR, like we keep a XOR variable, and XOR variable basically just does the XOR operation from picks element from nums1, and then in nums2 it basically does an XOR on each element and iterate through that. So it's O of n square, um, like operation, right? Because you're actually traversing both of the arrays. Um, cool. What is, yeah, XOR is basically just an bitwise operation, by the way. Uh, Sorry that I did not make that clear in the start, but XOR is just a bitwise operation, which is like I can have a truth table. I can show you. So 0, 0, 0, 1, 1, 0, and 1, 1, right? So this is a truth table. So if these values are XORed with each other, so if it's the same values, then the answer is 0. XOR value is 0, right? And if it's a different integers and XORed with 0, then the answer is actually the integer itself. So 1. Similarly, 1 XORed with 0 is 1, and 1 XORed with itself is actually 0. So here, what we understand the property of XOR is that it's actually also commutative. That means that the order does not matter. So 0, 0 or 0, 0, like, yeah, 0 obviously has the same values, but yeah, the order does not matter. So 1 XOR 2 is actually equal to 2 XOR 1. It's the same answer for both of them. Yeah, so from this, what we understand the property is that if it's the same element, if same element, then XOR value is 0, right? So 0, 0, 1, 1 values are 0, right? So that is the idea. Um, Going forward, if, yeah, that is the idea for the basically how we can do bitwise XOR and what is the truth table and what is XOR values. But let's coming back to the problem. The problem states that we have two arrays and yeah, need to create another array and XOR each elements of that array, right? So how we can optimize this instead of going through two for loops and going to going through both the arrays, how we can optimize this. using some properties of XOR actually. So let's understand that approach. So I said that if it's the same element, so if 2 XOR 2 is a 0, right? If it's the same element, then it's always going to be 0, right? Which means that we need to know how many times the same element occurs. So, and the other thing is that very important is that these nums values are actually XORed in the end. So you don't even need to calculate these. You can actually multiply these two arrays with itself and uh, find a way to instead of creating a nums3 array, we can directly use the nums1 and nums2 to get the final answer. So that's what I'm discussing here. So that is the idea, that if I have something like 2 1 3 and 10 to 5 0, right? So the length of this is 3, the length of this is 4, right? So we know that if it's multiplied, to the other array, then all these elements needs to occur how many times? 4 times, right? So by that I mean 2, 10 XORed with 2, 2. So I'm just using the two values here, right? Uh, 2 XORed with 5, 2 XORed with 0. So if you see here, actually 1, 2, 3, 4. So if all of these are XORed with each other, then we just get 10 to 5, 0, because this XORed with this is 0, this XORed with this is 0. So which essentially gives me the same array, right? Similarly, this one, if it's XORed again, this one is XORed again, it will give you the same value. So which means that we need to XOR this array itself, just not even considering these values, right? So yeah, we know that if these elements are basically, like, if there's any element that is occurring again, right, the frequency is 2, then we do not need to consider that, because if it's multiplied with each other, the value would be 0, right? So what we need to do is, because the first array is 3 values and the second array is 4 values, we need to XOR both of them and generate another array, or like we need to generate an answer such that that's an XOR between these two arrays. That is the answer. And yeah, so if I just know that I can XOR 2, 1, 3, and then 10, 2, 5, and 0, like basically all these elements, I don't need to consider these two because it's occurring two number of times. So what's better than using a hash map to store that frequency? So that's the approach one. So we store frequency of each element in a hash map, and if it's occurring like even number of times, we do not consider it, because yeah, it will be cancelled by itself, and other values we need to XOR together, right? So that's one approach. The other approach that you know and you observe and see is without the hash map. So without the hash map, you know that we need to consider basically if nums 2 and nums1 is been given, right? And we need to multiply nums1 with nums2, right? So we need to consider all the elements of nums1 if nums2 length is odd. Nums1 length is odd, then we need to use we need to consider nums2. And if nums2 length is odd, then we need to use nums1. By that, I mean 2, 1, 3, and 10, 2, 5, 0. So I know that this is even, so I do not consider any elements of nums1. Okay. And here I know that all the elements are odd, so I just consider using nums2, right? And if I just XOR both of these and return the value, it's going to give me the answer. So approach two is like, the insight is basically that if it's even, right? So we do not need to consider in nums1 in XOR operation, because basically this is multiplied to this one even number of times. So eventually we'll get 2, 2, or 2 going on so far. So for 1, 1, 1, and so on. So we'll get the values even number of times, and eventually all of them will be cancelled, and we will not have nums1. And essentially, the answer would just be an XOR between the nums2, right? So this is a key observation of approach 2, right? So that is the idea. Let's get to the coding part to do it and understand this a bit better. It's quite straightforward if you understand this observation that if the length of the nums2 is even, then nums1 does not exist. Or if nums2, if the nums1 length is even, right, then nums2 does not exist, right? So that is the idea. Let's solve it. Let's get to the coding part. So I'll maintain two XORs. So XOR 1 for the first array and XOR 2 for the second array, right? And I'll iterate through. So first of all, I'll say nums1 length is n1, so nums1 dot size, and int n2 is nums2 dot size. So if n1 modulus 2 is not equal to 0, so which means that if n2 actually, if the length of n2 is not even, then I can iterate through nums in nums1, and I can consider XOR 1 as XOR operation of nums, right? Similarly, if n1 mod 2 is not equal to 0, then I can iterate through nums2, and XOR 2 will be basically everything in nums2. And in the end, I just return XOR 1 modulo XOR 2, and that is the answer. Let's run the code to see if everything is working fine. Yeah, that works. Cool. I hope you guys understood the problem. Thank you so much.